Good morning to one and all. I'm Professor Raju Patil from Mechanical Department, Angli Engineering College, Belgavi. So I welcome you all for the today's session. I'll be handling energy engineering for you all. So the syllabus for the energy engineering is Module 1, Thermal Energy Conversion System. Okay, in that we'll be discussing of the Indian scenario of the India about related to energy. Okay, and different types of fuels used for steam generations, equipment for burning coal in lump pond, strokers, different types of oil burners, advantages and disadvantages of using polarized fuel, equipment for preparation and burning of polarized coal unit system, and bin system. Okay, polarized fuel furnaces, cyclone furnaces, coal and ash handling. Okay, and chimney, natural forced induced and balance draft calculations and numerical involving height of chimney. And along with that we'll be discussing about the accessories for the steam generator, that is superheaters, desuperheaters, control of superheaters, economizers, air preheaters and reheaters. Okay, and in module 2 we'll be discussing about the diesel engine power system, applications of diesel engines in power field method of starting diesel engines, auxiliaries like cooling and lubrication systems, filters and centrifuges, oil heaters, intake and exhaust system, layout of diesel power plant, hydroelectric energy. In that we'll be discussing about the hydrographs, flow duration and mass curves, etc. Okay, and in the module 3 we'll be discussing about the solar energy fundamentals, solar radiation, estimation of radiation data, solar thermal systems, introduction and basics of thermodynamics and heat transfer, and one more part of module 3, that is solar cell, module panel and array construction, photovoltaic thermal systems. And in module 4 we'll be discussing about wind energy, properties of wind, availability of wind energy in India, wind velocity, power from wind, major problems associated with wind power, wind machines, types of wind machines and their characteristics, horizontal, land, vertical axis and windmills, coefficient of performance of windmill, rotor and numerical examples will be solving. Okay, and in tidal, it's a part 2 be part of fourth module, that is tidal power, tides and waves as energy suppliers and the mechanics, fundamental and characteristics. Okay, and all limitations. And last will be the module 5, that is related to biomass energy. We'll be discussing about the biomass energy and photosynthesis here, and process of biofuels, biomass resources, biomass conversions technologies, urban waste to energy conversion, and part B of module 5, green energy, that is fuel cells overview, classification of fuel cells, operating principles of fuel cells, thermodynamics, nuclear ocean, and geothermal energy applications, origin and their types, working principle of zero energy concept. Okay, so textbooks we can refer B.H. Khanna, Non-Conventional Energy Resources, 3rd edition, M.C. Hill, Education, Principles of Energy Conversion, and reference books are S.P. Sukatme, Solar Energy, Principles of Thermal Collection and Storage, Tata Max Will Hill. These are the reference books. And next we'll start up with the module 1, thermal energy conversion system. Okay, so first part will go ahead with introductions. Energy is available in various forms: mechanical, electrical, thermal, etc. Okay, it can be converted from one form to another using suitable arrangements. Electrical energy is an essential gradient for industrial and all round development of any country. It is preferred for the following reasons: because it can be generated in bulk, can be easily economically transported from one place to another over long distance, can be easily and efficiently adapted to domestic and industrial work. Electrical energy can be generated conventionally from various sources such as fossil fuels, nuclear and hydro sources. Okay, and electrical energy can also be generated from various renewable energy sources such as tidal, wind, solar, geothermal sources. Okay, and energy scenario in India: the installed capacity of the country as on 31st March 2016 was uh, 3 lakh to 2088 mega MW, comprising of 2 lakhs 10,675 MW thermal and 5,780 MW nuclear and 4 lakh 2,784 megawatt hydro and 4 lakh 28,449 megawatts renewable. Renewable energy resources: the installed and capacity as on 31st March 2016 from renewable energy sources is 42,849 MW. So, with the Indian ranks fourth in the world in terms of installed capacity of wind turbine power plants. Okay, next in India as on 31st March 2016, the total RES capacity was 42,849 megawatts out of total installed generation capacity of 3 lakh 2,088. This represents almost 14.2% of the total installed capacity. So an action plan has been formulated by Government of India for achievement of total capacity of 175,000 MW from renewable energy sources by March 2022. So here, coal is the mainstay of India's energy sector, and the all India installed capacity of the country is about 302,088 MW as on 31st March 2016, out of which about 185 172.88 megawatts, that is 61.3% is a coal based. Okay, so electricity consumption per capita is the index of the living standard of the people of our country. Okay, the per capita energy consumption of India is still 600 MW while it is 12,000 MW in China. Okay, different types of fuels used for steam generation: steam power plant use for fossil fuels to generate steam. The fuel may be in different forms such as solid, liquid, pulverized or gaseous. Okay, solid fuels are coal is the most abundantly available fossil fuel, and coal is highly carbonaceous matter that has been formed from the prehistoric vegetable deposits which have been decomposed and solidified under combined effect of great pressure. Okay, so coal takes up a lot of space. Also, it is a heavy and dirt or to handle. The different form of coals are peat, lignite, bituminous coal and anthracite coal. The chemical substances in the coal are carbon 50 to 95%, hydrogen will be 1 to 5.5%, nitrogen 0.5 to 7%, oxygen to 40%, sulfur 0.5 to 3%. Okay. So liquid fuels, all type of liquid fuels used are derived from crude petroleum and its products. Okay, the petroleum or crude oil consists of 80 to 85% centigrade and 10 to 15% hydrogen and varying percentage of sulfur, nitrogen, oxygen, and etc. The advantages of liquid fuels: higher calorific value than the solid fuel, less ash formation as compared to solid fuel. They can be easily stored in tanks and require less space. Hence, handling becomes very easy. Okay, combustion can be controlled easily, easy to transport through pipes. Next, gaseous fuels. For the generation of steam in gas-fired thermal plants, either natural gas or manufactured gaseous fuels are used. And generally, natural gas is used for power plants as it is available in abundance. The natural gas is generally obtained from gas wells and petroleum wells. Okay, the major constituents in general gas is methane, about 60 to 65%, and also contains small amount of other hydrocarbons such as ethane, naphthalene, and aromatics, carbon dioxide, and nitrogen. The natural gas is transported from the source of place of use through pipes for distances to several hundred kilometers. Natural gas is colorless, odorless, and non-toxic. Equipment for burning coal. Coal may be fed into furnace for combustion in lump pieces of powder forms. Coal in point 0.1 solid fuel or lump form. Firing, mechanical stoker firing, and second one, that is pulverized fuel or powdered from in unit system or bin system. Okay, in mechanical stroker firing, uh, we can use the following. Even though this it is costlier, generally they are used to feed solid fuels in small and medium size power plant because of the following reasons. Uh, Combustion is more efficient, fuel handling is automatic, and combustion control is easier, faster response to load fluctuation, and low quality fuels can be successfully burnt, suitable for small to high capacity plants. And you all can see the principle of mechanical stroker firing. Point 1 over feed stroker. You all can see here the flame in curved shape. You all can see that is carbon dioxide plus oxygen plus nitrogen plus hydrogen. Okay, secondary air this is. Okay, you all can see the secondary air. Okay, and here you all can see the green coal. Okay, you can see the green coal below that. Below that you will be seeing the green coal. You all can see this green coal below this, and that is you all can see, and below that it is incandescent coal, and below that there is a ash, and at the last it is a grate. On grate it all these are formed. Okay, and these are the primary air water below that. Okay, this is the principle of mechanical stroker firing. Okay, and under feed stroker what comes here, the you all can see first of all uh, primary air water from this side, and the tire, on that tire the green coal is lying, and incandescent on that, above that incandescent coke is there, and ash and the flame. Okay. Next, types of stokers. Different types of stokers are overfeed stokers, that is conveyor stoker, chain gate stoker, traveling gate stoker, spread and the second one is spread stoker, and underfeed stokers, single retort stoker, multi retort stoker. So you all can see here chain and traveling gate stoker here. Okay. In this we see that front sprocket driven by a variable speed motor, this. Okay. And this is rear drive sprocket. You can see front driven sprocket and rear driven sprocket here. So okay, see here. mm, you all can see the air inlets controlled by the dampers. These are the air inlets controlled by the dampers. And the front ignition arc, you all can see this. And hopper, through hopper the coal is, first of all the coal is fed into the hopper, and what comes, the front sprocket driven will be through that, it is sent to the air inlets control dampers, and thus the fuel gases when it burn to ash pit. Here this is the ash pit, and when it burns, what happens, the fuel gases will be going upward. Okay. huh? And you all can see the process here. Okay. And next will be the advantages of chain stoker: simple in construction, low initial and maintenance cost, self-cleaning stoker, combustion control is simple by control of feed or chain speed along with air supply. Its combustion efficiency is high. Disadvantage of chain stoker: it is suitable only for small capacity plants. Coal losses are high as the unburnt coal may also move with ash. If caking coal is used, ash clinker problems may arise. Okay. So next will be weaving with spreader or sprinkler stoker. Okay. And this is in this, you all can see the coal hopper. Coal is fed into this, and it is into the feeder, and it spreads like anything. Okay. Spreader spreads with the this fan and air vents, and fuel bed is here in the furnace. This is the process: wind box and ash pit dumping rate. Okay. Next, advantages of spreader stoker: a wide variety of coal can be burnt, varying from a lignite to bituminous coal. Having high ash content can be burnt. The clinkering problems are reduced due to spreading action. The system provides thin and even fire bed and results in high rate of combustion. Next one, that is single retort stoker. Single retort stoker, you all can see here the hopper where we feed, and it reaches to the pusher. These are the pushers, and these are the retort. This darker line is retort. Above that the pushers are there, and above that the tires are there, and on that the coal is reached, and the above that is a boiler. Okay. This is the process of single retort stoker. And multi retort stoker, you all can see here multi retort stoker ram. You all can see the stoker ram, and these are the tires formed. On above that tires, the green coal is fed. So extension gate is used to lock or extend that, and draft gauge is used. Okay. And next, pulverized fuel burning. In pulverized fuel firing system, the coal is powdered and then charged into the combustion chamber with the help of hot air current. The air required to carry the pulverized coal and dry it before entering the combustion chamber is termed as primary air. You all can see here this this you all can see pulverizer. This is a pulverizer. Okay. Huh? First of all, the fan, and here you all can see this the primary air preheater is there, and primary air comes on that, and primary air fan where the pulverizer is there, and thus the coal is passed to the secondary air wind box and the burner. This is the burner last. Okay. Advantages of pulverized coal. A wide variety of low-grade fuels can be used and burnt easily. Greater surface area is exposed for combustion, and hence combustion is faster and efficient. Combustion control is easy, and hence the system gives fast response to the load changes. Okay, it gives fast responses to the load changes. Preheated secondary air can be used, resulting in rapid flame propagation and faster heat supply to the boiler. The pulverizing system can be maintained or repaired without affecting the combustion process, or as pulverizing equipment is located outside the furnace. It has very high rate of heat release. Okay. Disadvantages of pulverized coal. The capital investment of the system is high, as it requires additional equipment for pulverizing and handling. Its operation and maintenance costs are very high. It produces fly ash, fine dust, and needs costly fly ash removal equipments like electrostatics, precipitators. The chances of explosion are high as coal burns like a gas. The storage of powdered coal requires special attention as it has possibilities of fire hazards. Skilled workers are required for safe operations and maintenance. And pulverized fuel burning system. There are two common methods of pulverized fuel burning systems: unit system and central or bin system. You can see pulverized fuel burning. You first will be discussing about the unit system. So you all can see the raw coal is fed here and through the speeder. This is the hopper. Okay, raw coal burner and fed, and thus it is created with the air or fuel gas for coal driving, and thus it is separated. This is the separator which separates, and thus from through this the exhaust fan rotates, and this is the pulverizer which pulverizer sends to the separator, and thus it is sent to the burner and furnace. Okay. This is the process. And next one, advantage of unit system. You all can see it is simple in operation and cheaper. Direct control of combustion from pulverizing mill is possible here. Okay. Coal transportation system is also simple. Maintenance cost is low. Disadvantage: performance of pulverizing mill is poor as the system operates at variable loads. Unit system of fuel burning is less flexible. Whenever any of the auxiliary fails, the burner has to be put off here. Wear and tear of the fan blades is more since it handles hot air and cold particles. Strict maintenance of pulverizing mill is must for perfect operation of the system. So next we'll be discussing about the pulverizing fuel burning, that is central system. Okay, here you all can see the raw coal bunker. Raw coal is fed here, this feeder, and it goes to the pulverizing mill, and Here you all can see, you will go to the cyclone. Okay, you all can see the alternative fuel gas for drying. Okay, and the primary air fan also is available here. When it enters into the cyclone, central storage bin of pulverized coal is fed here to the burn feeder and is burned here. Okay, next, advantages of central system. There is always some coal is reserved, thus failure of mill will not affect the coal fed to the burner, and burner operation is independent of coal pulverization. Pulverizing mill can be shut down when sufficient capacity has been achieved. The same can be used during peak long periods. Disadvantages: central systems is expensive and occupies more space, and it requires complicated coal handling systems. Power consumption of auxiliary is high. Chances of free fire hazards are more since the pulverized fuel is stored here. Operation and maintenance charges are higher than the unit system of same capacity. Okay. Next, pulverized coal burners. Burners are devices that allows uniform mixing of fuel with air, hence lead to efficient and complete combustion. Burner receives the fuel along with the primary air in a central passage, while secondary air is supplied around the passage. Okay, the important requirement of an efficient pulverized coal burner as follows: it should mix the fuel and primary air thoroughly, and inject the mixture into the furnace. It should create proper turbulence for air fuel mixing and maintain a stable combustion.